Today topic is Avogadro's law. This is also belong to gaseous law. Scientist Avogadro explained the relation between V and T. He explained the relation between V and T. V versus T. That is the reason V versus N. N means number of moles. Already I told you the measurable properties are four, which are number one is pressure, number two is volume, and number three is absolute temperature, and number four is number of moles or mass. So now Avogadro scientists explain the relation between volume and number of moles. It means what you are not seeing, temperature you are not seeing here, and pressure you are not seeing. It means both are constant. At constant temperature and constant pressure, he explained the relation between volume and number of moles. So what is the statement? At constant temperature and pressure, the volume of a gas is directly proportional to the number of moles present in it. When you see the mathematical equation, V is directly proportional to N at constant temperature and pressure. When you remove the proportional symbol, you will get one constant, that is K. V is equal to K into 1 by N. So in case of two gases, we can write this in this pattern. V is equal to, the equation is V is directly proportional to number of moles. Number of moles we can represent it with small letter n. When you remove the proportional symbol, you will get K into N. So V by N is equal to K. Based on this also, you have to give the definition for Avogadro's law. At constant temperature and pressure, the volume of gas and its number of moles ratio is equal to one constant, K. So for example, this is considered as V1 N1 is equal to K. When same way V2 N2 is also equal to some constant. Based on both the equations, you can write V1 by N1 is equal to V2 by N2. So this formula is used to calculate the numericals. Before the experimental condition, initial volume, initial number of moles, after volume and after number of moles, final volume and final number of moles. That is the reason V1 by N1 is equal to V2 by N2. Okay. So one more definition I am saying in the down, equal volumes of all gases measured under the same conditions of temperature and pressure contains equal number of molecules. It means equal volumes of all gases, equal volumes of all gases, equal volumes of all gases contains equal number of moles, equal number of moles. This is also known as Avogadro's law. Equal number of moles is equal volume. Equal volume of all gases contains equal number of moles at same temperature and pressure, at constant temperature and pressure. What is the meaning of this means? For example, here I am taking two containers, two vessels. For example, this is A and this is B. So A I filled with hydrogen gas and B I am filling with oxygen gas. Both the volumes are 2 liters. This is 2 liter, this is 2 liter. 2 liter hydrogen gas, for example, it contains 10 molecules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These also consist with 10 molecules. So equal volume, 2 liter, whatever the number of moles are there here, for example, number of moles are 10. 2 liter oxygen also consists with 10 moles. When 2 liter carbon dioxide gas also when you take, how many moles it will be? This also 10 moles. It means equal volume, same liters, equal volumes of whatever the gas when you take, those gases will contain same number of molecules, same number of moles. Now this equation I am going to apply. We know the number of moles formula. We studied in basic concepts of chemistry, number of moles is equal to mass divided by molecular mass, mm or capital M. So where instead of N, I am substituting mass by molecular mass. So K into mass by molecular mass. In this way, you will get one more formula. M is equal to, M means molecular mass, small m means weight of the substance, V means volume of the gas. So M is equal to K into D, mass by volume. Also we can consider it as K into D. So in this case, you are getting two more formulas. One is V is equal to K into 1 by N. V is equal to K into M by M. V is equal to K into M by V. This V is coming here. Hence, M by V is considered as density. Instead of M by V, you can substitute density, mass by volume. So this is about the different approaches to explain the Avogadro's law. Second one is Gaylusaks law. Gaylusaks also explain the relation between measurable properties. We have taken P and T. P and T. Pressure versus temperature. Pressure is directly proportional to the temperature. So what are remaining are there here? Volume is you are not seeing, mass also you are not seeing. Fixed mass, constant volume, and the pressure is directly proportional to its absolute temperature. So that only there here the statement. The pressure of a given amount of a gas at constant volume is directly proportional to its absolute temperature. Mathematical representation, P is directly proportional to T. P is equal to some constant K into T. P by T is equal to constant. Based on this also you have to give the definition. The ratio of pressure and absolute temperature is equal to some constant K at fixed mass and volume. This is also known as Gaylusaks law. In case of two different conditions, P1 by T1 is equal to P2 by T2. My dear students, I explained you in Charles law. It is similar to Charles law. Once you observe, what is Charles law? V is directly proportional to capital T. Instead of V, what came here? Pressure is K. When V is equal to some constant K into T, then V by T is equal to some constant K. In case of two different conditions, V1 by T1 is equal to V2 by T2. This is what I am saying about Charles law. Okay. Charles law I have given you with a different approach. We can express in centigrade temperature also. Whenever absolute temperature is coming, there it is interlinked with Celsius temperature small t. The same Charles law I have written in the different pattern. When volume is equal to what I said, V naught plus V naught by 273 into small t. At that particular temperature, the volume will come. The same way, here also temperature, we are representing absolute temperature is there. So that the pressure is related with centigrade temperature, that equation you have to write. You can assume instead of Vt, what do you want to write? Pt. The pressure is equal to initial pressure plus how much pressure is going to add for every 1 degree raise in temperature? 1 by 273 will be add at every 1 degree raise in temperature. So that I am explaining you. Now listen carefully. This is the Gaylusaks law with respect to absolute temperature, and with respect to Celsius temperature I am showing you. Okay. Now pressure is equal to initial pressure. Each and every gas should have some pressure, that is the initial pressure, absolute pressure, It means that is 1 atmospheric pressure plus this P naught. How much amount should be added? 1 by 273 into at that particular temperature. So this equation I am going to write in different pattern. P is equal to P naught plus this T I am writing here, T by 273 into P naught. P naught. So now, for example, you are taking a container. Here a gaseous mixture is there. Entire this one is gaseous mixture. This gaseous mixture you are taken into a 273 parts. 1, 2, 3, 4, 5. Like that 273 parts are there. Where this is called as one part. 1 by 273. This is 1 by 273. 1 means what? That is V naught. 1 means V naught into V naught or V naught by 273. So when you increase 1 degree centigrade temperature, at that particular temperature, P is equal to what? What is the formula? P is equal to, tell me, P naught. Already it have some pressure is there. This is the gas. It is having P naught. This P naught, when you temperature increases, what increases? Temperature increases, pressure should be increases. How much pressure should be increases? This much pressure should be increases. 1 by 273 into, you are increasing 1 degree centigrade. So that is 1 degree centigrade. When you increase 10 degree centigrade temperature, at that particular, what is the pressure? So it is a original pressure plus 2 by 273 into 2. 2 times, sorry, into 10. 10 degree centigrade means into 10. So when you write here 10, here V naught. Why? This I am rearranging like this. Here 1 by 273 into P naught. Here 2 by 273 into P naught. When at particular, for example, 100 degree centigrade, at 100 degree centigrade, how much pressure should be increases? Pressure formula P is equal to P naught plus 100 degree means you have to write here 100 divided by 273 into P naught. So in this way, you can express the pressure with respect to centigrade temperature like Charles' law. So that I am going to show you. Just look at the screen. Pressure of a gas at 0 degree centigrade temperature is P0. How it will be? How it will be? Pressure is equal to, what is the formula? P naught plus T by 273 plus, sorry, into P naught. At 0 degree centigrade means what will you get? P is equal to P naught plus here 0, 0 by 273 into P naught. So everything should be 0. So at 0 degree centigrade temperature, the pressure is become what ma? P naught. That only I have written here. Pressure of a gas at 0 degree centigrade is equal to P naught. Pressure of a gas at 3 degree centigrade is PT. PT formula I have written P naught plus P naught into T by 273. Or this we can arrange in this way. This T is coming here. I am taking P naught is a common. P naught into 1 plus T by 273. PT is equal to P naught by, after simplification, 273 plus T by 273. Hence, finally P naught into TT by T naught. TT by T naught means what? Capital T is equal to, I told you, small t plus 273. So here, small t plus 273 is there. That is the reason I have written capital T at a particular temperature. So that TT. 273 means it is absolute temperature T naught. So what the equation you are getting? Pt is equal to, so Pt is equal to P naught into Tt divided by T naught. So this equation you can write in this format: Pt by P naught is equal to T at particular small t temperature, and this is absolute temperature. T means this is the final temperature always. That is the reason we have to take it as P2. P naught means initial pressure, that you have to take a P1. Tt means it is a final temperature T2. T naught means initial temperature T1. Like this equation and this equation both should be same. Pt by Tt is equal to P naught by T naught. P2 by T2 is equal to P1 by T1. Also, we can represent in this way also. P2 by P1 is equal to T2 by T1. Hence, based on all the above expressions, it indicates P is directly proportional to T. P is directly proportional to T. It means when this P is directly proportional to T, when you write in this format or this format, both should be same. To explain you, we are deriving in this pattern. So simply you have to remember P is directly proportional to T is nothing but what? Pt is equal to P naught plus P naught plus T by 273. If volume and number of moles are kept constant in any way, volume and mass is constant, hence the pressure is directly proportional to the absolute temperature. Now I am giving some questions, numerical questions. Based on this Avogadro's law and the Gaylusaks law, we'll see few questions on this. Consider 20 ml of hydrogen gas at temperature 0 degree centigrade and pressure 1 atma having the volume of 44.8 dm cube. Calculate the volume of 50 ml of nitrogen gas at the same temperature and pressure. So whenever you are doing the sum, first you have to underline the numericals. That is the reason I am giving different colors. So numerical numbers you have to underline this. Then only you will get an idea. 0 degree, 1 degree mean atmosphere means it is a STP condition. So volume they have given dm cube. Moles means number of moles. Moles they have given moles. Moles 2 times there. And you have to find out what? Calculate the volume. One volume they have given 20. Look at this thing. As from the Avogadro's law, at constant temperature and pressure, we know that V1 by N1 is equal to V2 by N2. So we know that all the values here, as per the question, they are asking about the volume. That volume we have to find out. V2 is equal to V1 by N1 into N2. As per the given data, see here, 44.8. Where is 44.8 here? This 44.8 is dm cube, means it is the unit for volume. So V1 is 44.8. They are asking V2. They are asking V2. We are going to calculate V2. V1, V2 is over. Next, V1 by N1. N1 means number of moles. Where is N1? 20 is there here. 20 moles of hydrogen N1 they have given. N2 50 moles of nitrogen they have given. Calculate 50 moles of nitrogen into 50. So you have to find out V2. So write the all values and substitute it. You will get the answer. Once again I am reading the question. Consider 20 moles of hydrogen gas at a temperature 0 degree centigrade and 1 atmosphere having the volume of 44.8 dm cube. Calculate the volume of 50 moles of nitrogen. So you are getting this. 20 moles is this much. How much? 44.8. So 50 moles is equal to how much? More than double. In that way, unitary method also you can do it. Why? Equal volumes of all gases having equal number of moles. So here 20 moles is 44.8 means 50 moles how much? In that way also you can do. Therefore, the volume is 112 dm cube. Second question. There is the addition of 2.5 liter of helium gas in 5 liter of helium balloon. 5 liter helium balloon is there already 5 liter. That already 5 liter helium balloon you are adding 2.5 liter. The balloon expands, then the balloon expands. Why you are adding extra volume? Expand such that the pressure and temperature remain constant. Estimate the final moles of gas if the gas initially possesses 8.0 moles. So all the values they have given, you have to find out the final volume. So same formula, V1 by N1 is equal to V2 by N2. So V2 is equal to 2.5 plus 5.0. Why I have written 2.5 plus this? Already the helium balloon is initial volume is 5.0 liters. There is the addition of 2.5 liter of helium gas in 5.0 liter of helium balloon. Already it is having some, this is the helium balloon. So this helium balloon, its volume is 5 liter. Now I am adding 2 liter. So total how much it is? 7.5 liter. Next. Formula we know that V1 by N1 is equal to V2 by N2. Substitute the values. N2 is equal to, you will get the formula N1 into V2 by V1. So N1 we have got it already given in the question, 8 moles into V2. V2 means initial volume plus final volume, 2.5 plus 5, that is 7.5. And V1 is the initial volume, that is 5 liter. You will get the answer 12 moles. The final number of moles in 7.5 liter of the gas is 12 moles. Third question. 3 liter of hydrogen reacts with oxygen to produce water vapor. Calculate the volume of oxygen consumed during the reaction. So, you know about Avogadro's law? Equal volumes of all gases having equal number of moles. For the consumption of every 1 mole of hydrogen gas, half mole of oxygen is consumed. In this case, you have to apply your some little logic and knowledge. What's the question? 3 liter of hydrogen gas reacts with oxygen to produce water. You know how the water will form. I am writing the equation. What is that? H2 plus O2 gives H2O. When you observe clearly here, two hydrogens, here two oxygen, one oxygen only there. To better understand and this equation, I am going to alter this H2 plus half O2, then H2O. It means one volume, 1 mole means 1 volume, no. 1 volume H2 is utilized in this reaction, right? How many volumes is utilized oxygen? Plus half volume. Half volume is involved in this reaction O2. Oxygen is half volume. Finally, we are not about discussing about water. We need about, based upon the question, this one. Anyhow, you can write 1 volume of water is forming. 1 volume H2O is obtained. When you understand this equation, easy to solve this question. Very simple, 1 mole is nothing but 1 volume. 1 mole is nothing but, remember, it is considered as 1 volume of hydrogen gas reacts with 1 volume of oxygen gas. No. Half volume of oxygen gas that produces 1 volume of water molecule. When 3 volumes of hydrogen is reacting, expect answer. 3 volumes of hydrogen is reacting. 3 volumes of hydrogen reacts. In this case, they have given 3 liter means 3 volumes, 3 liter. Okay. How much oxygen is required for this? Anyone can guess this answer? If 1 volume, half. 1 volume, you required half volume of oxygen. When 3 volumes utilized hydrogen, how much? Excellent. So, So 3 into half, right? It means that is 1.5. That I am going to show you. Look at the screen. NO2 is equal to half H2O. As per the Avogadro's law, the volume is directly proportional to moles. So we can write the above equation in this format. So oxygen is equal to half H2. Half means 3.0 into half is equal to 1.5 liter. 1 point liter, 5 liter is the answer. How? 1 liter is giving unitary method, you can go simply 3 liters. You require how much volume of oxygen? This is 3 liters hydrogen. As per the data, 1 liter, 1 volume means 1 liter requires half liter oxygen. 1 liter H2 requires how much? Half liter oxygen. Then 3 liter H2 requires how much? 3 into 1 by 2 is equal to 1.5 liter. So this is the answer. I am going to give you some more questions based upon Avogadro's law. Go through the Avogadro's law and do the numericals, then only you will get the perfection, whatever I am explaining. If 5 grams of 2 grams 5 grams of oxygen gas has a volume of 7.20 liters at certain temperature and pressure. What volume does 15.0 grams of O2 have under the same conditions? Given values you have to underline and calculate the what volume. Next question. If this number is came 2 times, if 4 grams, this is not there. If 4 grams of helium gas occupies a volume of 22.4 liter at 0 degree centigrade and a pressure of 1 atmosphere, what volume does 3 grams occupies under the same conditions? If 3.25 moles of argon gas occupies a volume of 100 liter at a particular temperature and pressure, what volume does 14.15 moles of argon occupy under the same conditions? Next question. If 23.2 grams of a given gas occupies a volume of 93.2 liter at a particular temperature and pressure, what mass of the gas occupies a volume of 10.4 liters under the same conditions? So this is about the 5 questions as a worksheet. Please go through that. You will get an idea how V1 by N1 is equal to V2 by N2. In all the cases, the same formula is applicable. So 3 values they have given, you have to go to calculate only one variable, 1. Now what about the graph between pressure and temperature? This is explained by the Gaylusaks. When whatever the graph plotted between pressure and temperature, that is in chemistry term, that graph name is known as isochore. Isochore means the graph between pressure and temperature. So it is also moving a straight line, y is equal to mx pattern. So whatever the forms are there, 3 forms we have given, V is equal to K into 1 by V. Number 2, V is equal to K into T. Number 3, V here P. P is equal to K into T. These 3 equations will give same graphical representation, this one only. This is this one only, because These all equations look like y is equal to mx. Y is equal to m dot x. So here these all are slopes, and this is here 1 by v, we can treat it as one component. This is t, here also t. These are all indicates x. So same way here also the thing is that it is moving to the straight line, because when temperature increases, pressure increases. See here, at this particular pressure, this is the temperature. At this particular pressure, when pressure increases, what happened? Temperature increases. Temperature increases, pressure increases. This is moving towards this direction. This is moving towards this direction. So always pressure and temperature both are directly proportional to each other. And different volumes. See here, at different volumes, the pressure and temperature. Here I have taken one. No confusion, ma. I'm going to show you, my dear students. For example, this is one container. It has some volume that I am indicating with V1. And another container is there. It is also having some volume. This volume I am indicating with V2. Another container is there. This is also having some volume, initial volume. This I am indicating with V3. Got it? When you write the graph, pressure versus temperature, you will get only straight line like this. So for V1, I have drawn straight line because it is having this much volume. This is the volume. This is the volume. Okay. And when go to V2, it is having some extra volume. That is the reason here. When volume increases, pressure what will happen? Volume and pressure always inversely proportional to each other. So volume increases, pressure is decreases. So temperature increases, pressure increases. So at this particular temperature, this is the pressure. So finally, what I mean to say is, different gases is having different volumes. So lower volume is always less than higher volume. The volume is V2 means higher volume, V3 means higher volume, V4 means the greatest volume, a bigger volume. Okay, volumes are increases here. What I mean to say, whatever the volume you are taking, while heating the temperature, pressure increases. Why heating the temperature, pressure increases? These are the gaseous molecules. When you apply the heat, all the gaseous molecules bombarded with each other, accident with each other, either with container and molecule, and then pressure increases. When temperature increases, what is increasing? Pressure is increasing. Okay. For this gas, for another gas also temperature increases, any gas, pressure also increases. But all the gases are going to cool at one temperature, we have studied. This is heating. When you cool at particular 273 degrees centigrade temperature, degree minus 273 degrees centigrade temperature, whatever the volume you are taken, that should be, the volume should be zero. That is known as absolute volume. I am going to show the third one. See here. These are all graphical representations express the Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law as per the definition. So this is the Boyle's law. When pressure increases, volume decreases. At particular this pressure, the volume is, at this pressure, the volume is this one. Highest pressure, low volume. Then here, volume versus temperature. Temperature increases, volume increases. Here the temperature versus pressure, and this is volume versus number of moles. These are the four graphical representation comparative study, Boyle's, Charles, and Avogadro's Gay-Lussac's law. See here, I have given one flow chart, entire 3 days topic will come in only this slide only. What is that? The first one, Boyle's law, explain the relation between P and V. See here, this is the P and this is the V. Now, Gaylusaks law, explain the relation between pressure and temperature. Avogadro's law, explain the relation between volume and number of moles. Okay, so this is about the gas laws, and tomorrow we are going to learn